All right, so for this question that we have today, we have a very basic setup of a crane or a lifting device. It is a truss system and it is under equilibrium. We are asked to find the reaction forces and the members. The base over here, at point A, we have a rolling support, and at point D, we have a pin support. Over here, because it's a crane, it's lifting a load of 50 newtons, and we don't know the force coming through this. This is the other part of the rope that's pulling up this 50 newtons, and it is at 20 degrees. So I haven't given you the 50 newtons force because the first thing we're going to do is write down that this force over here is actually, which color do we want for forces? Let's go purple. This force over here is actually 50 newtons. Because this is a very simple system. If you have a rope over here, if this rope is feeling 50 newtons going this way, then if I'm pulling at it, it's going to be 50 newtons over there. So we have 50 newtons and we have an angle. Next, as we solve all our truss analysis questions, we go through with our setup over here of our 6 points of how to solve for reaction forces. We're going to identify the supports. We've already done that. We have to draw what the forces are for them, as in one at the vertical only and yada yada yada. Define equilibrium. We have that. And then we're going to identify and simplify loads. We've already got our simplified loads, and then we can just go straight to point 5 and 6, which is the sum of all moments about the rolling support. Sum of all moments around the pin support. And then sum of all forces, vertical and horizontal. So let's start by writing down our forces. This over here is a rolling support, so it's only producing a force in this direction. And this over here is a pin joint, so it's able to produce forces in this direction and let's say this direction. My assumption straight away is that let me unfocus the camera. My assumption is that the horizontal component of the there we go. The horizontal component of the force on D of this pin support is going to be heading to the right, because this over here force is going to the left. So I know something in this system is going to have to counter this force going to the left, and I'm going to assume this is going to the right. And if my answer is a negative, then I know that that assumption was incorrect. But we can solve that later. We already have all our simplified loads, so we can go straight to... I should label this as well. So we have force A vertical. This is force D vertical and force D horizontal. So let's go and do our moments. So we want to do moments about this pin joint to find this horizontal. So let's start by... Where did my pen go? Here it is. Alright, so we're going to do sum of all forces. Sorry, sum of all moments. My bad. Sum of all moments about point D, where clockwise is positive, equals 0. So 0 is going to equal. We have this over here. This is a clockwise. It's going to spin it this clockwise of 1 meter. So we have FAV positive. Then we have this force over here, 50 newtons. This one's going is also going clockwise, because it's going to also spin the thing this way. So we have plus 50 newtons times 1, because its distance is also going to be 1. Now the difficult one we have here is this. This over here is 50 newtons. And this is 50 newtons. It is at an angle. It's at 20 degrees. So what this means is, if we did this question graphically for some reason, if we had this force going off like this, right, we actually need to find this distance over here. Right? We need to find this, we have to find this distance over here. Let's just call this x for now. We would have to find this x over here. because that is the perpendicular distance. All right? And we can find that distance because we know we can find out what this length is. We can find out that this over here is just going to be the square root of square root of 2, right? Because it's the square root of 1 squared plus 1 squared, because it's a right angle triangle. And this angle over here, if this whole angle over here is going to be 45 degrees, this over here is 20, so that means this angle in here has to be 25. So then we can, with that, find out what our distance for x is. So let's write that out. So, and that is going to be, we'll worry about the direction it's going in later, so it could be plus or minus. I'll just leave that blank. That is okay, so because we can use our sine rule, so sine is opposite over hypotenuse, and so if we then solve for opposite, we are going to get sine 25 times root 2, and this over here, if this force is going in this direction, right, so it's pushing against the thing this way, it is spinning counterclockwise. So this is going to be a negative. So if we solve over here, we should have force AV is going to equal force AV is going to equal sorry. This over here is just our distance. This is sine 25 times root 2. We then also got to times that by the actual force, which is 50. Alright, so now we have, if we do the maths, we should have sine 25 times root 2 times 50 equals 29.88. Let's do 2 decimal places, why not? Minus 50 minus 20.11. So we already have an answer here. We have minus 20.11, and it's going to be in newtons because everything else is in newtons. So what does this mean? One, it means that it is our force number, but it is a negative. We originally assumed that our force here was going up. So we have we know our answer is negative, which means our original assumption of this force going up was not correct. Our force is actually going down. So we'll draw there with an arrow. Our force is actually going down, and it is equal to 20.11 newtons. Okay, now we can do our sum of all forces vertical and sum of all forces horizontal. This is the case where if you already put this into vector form, as in horizontal and vertical components, your life is going to be slightly easier right now. Let's go sum of all forces vertical, where up is positive, equals 0. Let's go and get all our vertical forces we have here. We have a minus 20.11. We have, let's assume this is a positive force dV. We have minus 50, and we want to get the vertical component of this, which should be sine 20 times 50, and that should be going down. So minus sine 20 times 50. If we plug that all in, we should get our force dV equals, let's just clear this so we're all in 2 decimal places, Actually, these will all be positive. 20.11 plus 50 plus sine 20 times 50. We should have 87.21 newtons. And our answer is a positive answer. So our original assumption of this force going up is correct. So we will put this as 87.21. And now we have to finish it off with sum of all forces horizontal, where we'll say going to the right is positive, equals 0, equals nothing. So no, no, no. But we have these two. These are our two forces that have something to do with horizontal. So we can say force DH minus, well, if this was sine 20, the horizontal has to be cos 20. Cos 20 times 50, and we can just solve that. Cos 20 times 50 equals 40 FDH equals 46.98 newtons. So over here we have the first part of this question solved. We have all our reaction forces. So now we can Alright, so now we are ready to solve for all our individual members. We could pick a trickier member, like this one over here is going to have forces going off in two directions and two unknowns. So this one over here is going to require simultaneous equations if we want to solve it first. This one over here is unsolvable right now because it has three unknowns. Right? This over here has 1, 2, 3 unknowns as well. But we might be able to solve it with sum of all forces because some of those are going to be eliminated. But if we're given the easiest choice, this over here, it looks like the easiest one to solve because it only has two unknowns. And one of those unknowns is not the same as our force. So when we want to do sum of all forces horizontal, we're only going to have one unknown in that equation, so we can solve that equation quite easily. So we're going to start with A. A will give us, so if we start on node A, it's going to give us AB and AD, and then once we have that, we can then solve the rest real quickly. Well, quickly enough. So I'm going to go over to my next page now. Let me actually, how do I do this? Give me a second. Alright, so, where'd my highlighters go? I have lost my highlighters. Here we go. Alright, so the first thing we're going to solve, we're going to solve for point A. Alright, so we'll go over to a new page over here, and if we zoom into point A is, we have a thing going off here, we have a thing over here. We have a force going down of, this is 20.11 newtons. This over here is going to be force AB, and this is going to be force AD. Fab and FAD. And their angles are 45 because everything in this example is 1 degree, so we can solve that. So let's go and do our, let's do some assumptions. Let's assume that, let's do blue is tension. So if this over here is a force going down, we need something that is going to be providing an up force. And out of these two, Fab is the only one that can produce an up force. So we have an arrow for Fab is going to be going upwards. Right, so now we have introduced a horizontal force. This has a force that is going to the right, and so the only other thing that has a force that can have a horizontal component is FAD, so it has to have a force that is going to the left. And then I've already colored these arrows to tell me what that assumes. I'm assuming because this FAB is going away from the node, that's going to be under tension. And because FAD is going towards the node, I'm assuming this is going to be compression. So now let's go and solve it. Let's do our sum of all forces horizontal equals 0. Equals, sorry, not horizontal, vertical. We have minus 20.11. Then we have plus the horizontal component of this. Well, we're lucky that these are all in 45 degrees, so it doesn't matter which one we pick. But just for consistency, let's pick sine 45 should be the vertical component. So we should say sine 45 times FAB, and then FAB, if we plug that into the calculator, we should be getting FAB is going to equal 20.11 divided by sine 45 should give us 28.45. 28.44, sorry. 28.44 newtons, and our answer is positive, which means our original assumption was correct. So let's move on to the next one. Let's do sum of all forces horizontal equals 0. This has a horizontal component over here. So this horizontal component is going to be cos 45 times 28.44, because this is the number we just got from before here. And this over here, FAD is going to be negative FAD. So FAD is going to equal should be the same, right? It should be 20.11, but let me just check if there's a rounding. 45 times, yep, so we should have over here 20.11 newtons. And our answer over here is positive, so that means our original assumption is correct. Okay, so we have this, so let's go back to our original diagram and just write our forces in here. So we have 20.11 C for compression, and the top is going to be 28.44 T. Then let's go and let's do member D now. Let's use another color. Let's go with, pink. All right, now we'll do D, and D should look like, D has, we have a force going here, we have a force going here, we have a force going here, and then we have, we already have some of these values. This one over here is going to be 20.11 newtons going towards the node. And then we have our reaction forces, where we have, what do we have for our reaction forces? We have up, and we have this way. And this reaction force is going to be 87.22, and this one over here is going to be 4698. I think, is that the numbers I did? 2-1. Alright, cool. Alright, and then now this one is we're going to make some weird assumptions. We do over here have a force that is going, we have two forces here that are going to the left, sorry, going to the right. So we know this force over here, this one has to be going down. So we can put an arrow going over here. But now we are given with a scenario where we cannot guarantee the direction of this, because This over here is guaranteed having to go to the left because we have a right force and a right force. This is the only thing that can produce a left force. But when we have a vertical, we have this has an up force and this has a down force. We don't know which one of these is going to be bigger. So we're just going to assume something for this. And let's just assume that, so I'm going to draw it in pencil, so I'm not sure of the color. I'm just going to assume it's going up. I'm just going to assume it's going up, and I'll put it in pencil, so I'm not sure. And when I get my answer, I'll prove that. So let's start by doing the easiest one in this case, which is going to be the sum of all forces horizontal, because we're actually able to guarantee that this is horizontal component, horizontal component, horizontal component. So let's solve that. We have, and these numbers is this FAC and FBD. Alright, so let's do sum of all forces horizontal equals 0, equals, over here we have plus 20.11 plus 46.98. We're going to assume this is minus, and again this is going to be at 45 degrees. This is going to be at 45 degrees, which means, and this is going to be our cos. So minus cos 45 times FAC. FAC should then equal, I might as well write this one out because this one looks a bit tricky. Going to be 20.11 plus 46.98. That all over cos 45. And then if we plug that into the calculator, we should get an answer of 20.11 plus 46.98 all over cos 45. Give us an answer of 94.88. Yep, it's close enough. 94.88 newtons. And the answer is positive, which means that our original assumption was correct. I'd be very concerned if this was incorrect. But now we are going to do the sum of all forces vertical, and we're going to find out if this assumption was correct or not. Sum of all forces vertical equals 0. Well, this, we ignore this, we ignore this. We have this force, we have the horizontal, we have this force, and we have the vertical component of this force and this one. So we have 87.21. We have minus sine 45 times 94.88, and then we have plus FBD, which means FBD is going to equal FBD is going to equal sine 45 times 9488 minus 87.21, which is going to equal times 94.88 minus 87.21. It's going to equal minus 20.11. Now, we have a minus here. So what this minus means is that our original assumption that it was going to be going away from the node, or tension, was incorrect. So it's actually going to be we're going to redraw it to go down. So it's actually under compression. So we can say here, we can say tension, which equals 20.11 compression. So we know we've done that. That's under compression. Next, we only have to find one more node. We can probably do it with the last one, right? The last node we have to find. We don't even have to do node 3. We can go straight to. We can go straight onto node 2, which is going to look like this and this and this, and we know that this is over here. It's going that way. We've already determined this is under tension. So we have a, well, this is going up, that's going down, so that makes sense. This is going left, so this has to go right. So if it's going right, it's going to be under tension this way. And we have all our values. We have 20.11, and fab is 28.44, and so we can just go quick maths. We can go sum of all forces horizontal equals 0, equals, well, this over here is force BC, is going to equal force BC minus, if we, let's just say this is 45 over here, that would be cos, no, sine 45 times 28.44, and so FBC equals sine should equal 20.11 newtons. Alright, so, and we don't have to do sum of all forces vertical because that doesn't, we already know both of our vertical equations. So what we've done here is we've actually solved for all our individual members. We have force BC is going to be 20.11 T. We have force AC is going to be 94.88 compression. We have FBD, which is 20.11 compression. And yeah, so we have 1, 2, 3, 4, 5. We have all 5 forces solved. And that's how we're going to solve questions using the truss analysis. And if you want to look at other tutorials for this online, this is called the method of joints, because we are finding it by doing each individual joint one at a time.